So hello friends and welcome to our YouTube channel Marine Expert. Today we are going to study about boil water test. Boil water test बहुत frequently पूछा जाता है क्लास 2 orals में और क्लास 4 orals में भी. So we are going to look at it. But boil water test पढ़ने से पहले हम देखेंगे कि why we have to do boil water test at all. So what are the major problems that we face in a boiler? So there are three major problems, that is corrosion, carryover and scaling. So we will look at it one by one. So first problem that we face in boiler is corrosion. So corrosion is the process of slowly eating up metals by gas and water vapor present in the atmosphere due to the formation of certain compound like oxide, sulphite and carbonate. So basically it converts it into a refined metal and into a more chemically stable oxide. So what are the problem that we face due to corrosion? कोरोजन होने से होता क्या है कि जो हमारा ट्यूब मेटल सरफेस है वो ईटन अवे हो जाता है, तो धीरे धीरे उसकी थिकनेस जो है कम हो जाती है. एट एट द एंड बॉयलर ट्यूब में या और भी किसी मेटल में छेद हो जाता है, जैसे कि हम इसमें देख सकते हैं. सो बॉयलर लीकिंग स्टार्ट हो जाता है. सो टाइप्स ऑफ कोरोजन इन बॉयलर. So there are basically different type of corrosion. One is pitting corrosion, other is stress corrosion. Then we have crevice corrosion, caustic corrosion and caustic embrittlement. सो जो नॉर्मली सर्वेयर पूछते हैं वो पूछते हैं कॉस्टिक इम्ब्रिटलमेंट के बारे में, बट समटाइम दे डू आस्क अबाउट कॉस्टिक करोजन एंड क्रेविस करोजन ऑल्सो. सो वी विल लुक एट दिस वन बाय वन. सो pitting corrosion. What is pitting corrosion? So pitting corrosion is localized form of corrosion. So if somebody asks you what is pitting corrosion, that is the word that they want to listen, that it is a localized form of corrosion. तो होता क्या है हमारे पास, इसमें हमारे पास एक पेरेंट मेटल है यहाँ पे और एक है हमारे पास प्रोटेक्टिव कोटिंग. सो जब प्रोटेक्टिव कोटिंग हमारी ब्रेक हो जाती है, इट कैन ब्रेक ड्यू टू एनी रीजन. सो व्हाट कुड बी द रीजन ऑफ ब्रेकिंग दिस protective coating? This can be presence of acidity in the liquid or low dissolved oxygen or high concentration of chloride. The another reason may be poor application of protective coating, or if there is any non-uniformity in the metal structure. So these are the things that can lead to the breakage of this protective coating. So जब protective coating टूट जाती है तो base metal comes in the contact with the external environment. So after that corrosion starts. So evidence of pitting is usually found in the boiler shell around the water level and is mostly caused by poor storage procedure when the boiler is shut down for long intervals. So after pitting corrosion comes the stress corrosion. So stress corrosion cracking is the process caused by the combined action of heavy stress and corrosive environment. If stress are locked up within the metal, they can be partly relieved by corrosion, thereby exposing more metal by breaking the protective film. So इसमें होता क्या हमारे पास 4 steps है हमारे पास. First is film breakdown, second one is formation of pit, third one is stress corrosion cracking, fourth one is failure. So due to any reason that I have previously mentioned, film may break down, and once the film break down, the formation of pit start. So due to the presence of residual stresses, so residual stresses, this is the word that the surveyor want to listen. So due to the presence of residual stresses, stress corrosion cracking occur, and once this cracking start, it propagates due to the residual stresses again, and the finally failure occur and the tube fails. After that comes the crevice corrosion. So crevice corrosion, consider you have a crack and some amount of water gets trapped in the crack. So consider this is the surface, this is the crack, and this is the surface continued. So if water is flowing over the surface, some amount of water get trapped in this crack. So we have two different velocities here. One is the velocity of this water that is moving above this, and the another one is that is inside this crack. So this velocity difference will create potential difference. So the crack will become a node due to which it loses electron and material start to be removed. This will cause crack to become bigger. So that is crevice corrosion. After that comes caustic corrosion. So what is caustic corrosion? It is due to the presence of NaOH, caustic soda, and at high pH level. And after corrosion, caustic corrosion comes caustic embrittlement. So caustic embrittlement is like occur at very high concentration of caustic soda, uh, sodium hydroxide. So normally such high amount of caustic soda is not present in boiler water. So why do we face problem of caustic embrittlement? So the thing is, we have a boiler. If there is a small crack in the boiler surface, boiler shell, so the temperature inside the boiler is around 150 to 170 degree depending on the pressure. If it is 5 to 7 bar, so the temperature is around 150 to 170 degrees Celsius. So if there is any crack, water comes out, and outer pressure like atmospheric pressure, the boiling point of water is around 100 degrees Celsius. So once the water comes out, it flash off, and it with the flashing off, that is evaporation of water only. It leaves behind the salt, the NaOH. So water evaporates and leave behind the NaOH. So this lead to the high concentration of NaOH at the site. So at that site, intercrystalline fracture occur. So that leads to the caustic embrittlement. So that is about the caustic embrittlement. After that, we will study carryover. So if somebody asks you what is carryover, carryover is any contaminant that leave the boiler with the steam. It can be either solid, liquid, or gas. It can be either of these. So what are the effect of carryover? So if solid is living with the steam, small solid particle may go and stuck in the control valve orifices. So it will choke the orifice and hamper the functioning of control valve, or it can go and deposit on the turbine. So what will happen? The turbine blade may unbalance, or superheater. If it will go and stick on the superheater, it will form scaling, and the temperature transfer or the transfer of heat hampers. So the efficiency of boiler or the superheater will reduce. So priming is the carryover of varying amount of droplet of water in the steam. It can be mist or foam. So it can be in either form, either mist or foam. So what are the problem that we face due to priming? This priming may be caused by the improper construction of boiler, excessive rating, or sudden fluctuation in the steam demand. So these are the reasons, like avoiding high water level we can avoid, excessive boiler load, and sudden load changes. So sudden load changes. So that is why we always slowly open the steam whenever we are opening any valve or uh, main main steam stop valve. So to avoid priming. So to avoid priming also we add chemical that is anti-foaming and anti-priming agent. And what is foaming? It is the formation of thick layer of steam bubble on the top of water surface inside the boiler due to high concentration of impurities. So what are the problems that we face due to foaming? Like if a thin layer of a steam bubble forms on the top of the water level, then it sends the false indication to the water level indicator. So it can sense that the water level is less or water level is high uh, due to the steam bubble. So it it is not now, it faces problem to maintain the exact boiler water level if there is foaming. So scaling as we have already discussed, it is the formation of thick layer of suspended particle on the surface of the boil water tubes. सो दैट इज स्केलिंग. सो इसके कारण प्रॉब्लम क्या फेस करते हैं हम, इसके कारण लोकल ओवर हीटिंग होती है, हॉटस्पॉट बनते हैं, एंड बॉयलर इंटरफेसेस विद द हीट ट्रांसफर रेट हमारे पास कम हो जाता है. सो दे कंडक्ट लेस हीट एंड द मोर डेंजरस दे आर. सो एफिशिएंसी ऑफ द बॉयलर रिड्यूसेस drastically. So these are the topics, these are the problem that we face in the boiler. So अभी मैंने इसको सब ब्रीफ में डिस्कस किया बिकॉज द टॉपिक ऑफ दिस वीडियो इज नॉट this problem, but the topic is the boiler water test. So if you want to discuss this problem in detail, we can make a separate video. So after that comes the alkalinity. So alkalinity हमारे पास तीन तरीके से होती है, p alkalinity होती है, t alkalinity होती है एंड m alkalinity होती है. So alkalinity होती किसकी वजह से हमारे पास, it is due to the presence of hydroxide, that is OH, carbonate, that is CO3, and bicarbonate, that is HCO3. So first we will understand what is P alkalinity, then we will understand T alkalinity, and after that we will understand what is the difference between the P alkalinity, T alkalinity, and M alkalinity. So sometimes surveyor do ask the difference between the T and M alkalinity. So what we have to do, we have to take 100 ml sample of boiler water. Then we will add 10 drops of phenolphthalein solution, that is the indicator, and we will add N/50 sulfuric acid to clear the sample. So how do we calculate it? We will calculate it by, we will count the drops of N/50 sulfuric acid that we added, and we will multiply it by 10. That will give us the ppm of CaCO3. So the reaction here is CaOH2 plus H2SO4 gives us CaSO4. So the thing to understand here is that the phenolphthalein is less alkaline than the hydroxide or carbonate. So when we add phenolphthalein indicator, it will turn pink in color. The acid used for this coloration will first neutralize the hydroxide forming salt, uh, and then it will react with the carbonate molecule present. So first it will react with the hydroxide, then it will react with the carbonate present. So and it will form a bicarbonate molecule. So bicarbonate molecule are less alkaline than the phenolphthalein. Hence the pink coloration will disappear once all the hydroxide and carbonate have been dealt with by the acid. So in P alkalinity we add phenolphthalein, that gives us the amount of OH and half of CO3. So why half? Because you can see from this reaction that the bicarbonate, one molecule of bicarbonate is formed by the two molecules of CO3, CaCO3. So the P alkalinity gives us the amount of hydroxide and half the amount of CO3 present. So after that we will study about the T alkalinity test. So I think you understood here that first of all we have OH, then we have carbonate. Uh, this is more alkaline than the carbonate, CO3, and then we have phenolphthalein solution, and after that we have HCO3. So this is the decreasing order of alkalinity. So that is why P alkalinity gives us alkalinity due to hydroxide, that is OH minus, and CO3 minus. So that is the concept. So what will we do after that? We will study about T alkalinity. So T alkalinity, here after that we can add methyl orange also. So methyl orange is less alkaline than bicarbonate also. So once we will add methyl orange, it will gives us alkalinity due to OH minus, CO3 minus and HCO3 minus. तो इन तीनों की वजह से अपने को जो alkalinity मिला वो हमको मिथाइल ऑरेंज देगा. So that is T alkalinity test. सो इन टी एल्कलिनिटी टेस्ट जो एक बात ध्यान रखना है, हमने जो हमने सॉल्यूशन ये वाला यूज किया था, जो हमने सैंपल, इसी सैंपल में हम जब टेस्ट को कंटिन्यू करेंगे तो हम उसको टी एल्कलिनिटी टेस्ट बोलेंगे. So take alkalinity to the phenolphthalein sample. That is the thing that we have to remember. And what will happen if we will take new solution? If we will take new solution and we will add methyl orange, so it will give us the same value of the alkalinity, but then we call it M alkalinity test. Why? Because we know the total alkalinity in M alkalinity test, but we do not know how much is due to the presence of OH minus and CO3 and how much is due to the bicarbonate. But in T alkalinity test, we know that how much the alkalinity is due to the bicarbonate test. So that is the difference between T and M alkalinity. In T alkalinity, we know exactly how much is due to the bicarbonate and how much is due to the OH and CO3. But in L alkalinity, we know the total value, but we do not know how much each of this chemical contributing toward the alkalinity. So solution reaction you can see from here. We will take the sample to the phenolphthalein alkalinity, then we will add 10 drops of methyl orange, and we will count the number of drops of sulfuric acid we added until it comes pink. So ml of N by 50 acid used for both test into 10 will give us the ppm of CaCO3. So this is the table, and from here we can see if P alkalinity is 0, and then the total alkalinity is equal to the bicarbonate alkalinity, because P alkalinity is 0, that indicates us there are no hydroxide present and there are no carbonate present in the solution. So the total alkalinity is due to the presence of bicarbonate only. If P alkalinity is due to the total alkalinity, then it indicates that the total alkalinity is due to the hydroxide alkalinity, because no carbonate or no bicarbonate are present. And similarly, if P alkalinity is lesser than the half of total alkalinity, then it means that the total alkalinity is due to the carbonate alkalinity. So after that comes the caustic alkalinity. So caustic alkalinity gives us alkalinity due to the OH minus, caustic soda basically, OH minus. So what will we do? We will take 100 ml sample of boiler water, and then we will add 10 ml of barium chloride. So barium chloride 10 ml. So why we are adding barium chloride? Barium chloride is first added to boiler water sample in order to precipitate all the carbonate which are present. So once all the carbonate dealt with, we can simply get alkalinity due to the OH minus. So carbonate को हमने टैकल कर लिया बेरियम क्लोराइड के साथ. तो जब बेरियम क्लोराइड ने सारा कार्बोनेट को टैकल कर लिया, तो हमने सिंपली फिनोल्फथलीन ऐड किया, सल्फ्यूरिक एसिड ऐड किया, 10 से मल्टीप्लाई किया, और CaCO3 हमको ppm of CaCO3 टर्म्स में अपने को कॉस्टिक एल्कलिनिटी मिल गई. So that is the reaction. Barium chloride react with the CaCO3, gives us barium carbonate and calcium chloride. And here we have calcium hydroxide, and H2SO4 gives us calcium sulfate and 2 molecules of water. So chloride test. Now we have to understand chloride test. So chloride may be present in the boiler water sample, and it is essential that they be measured, as they would be an indication of salt water leakage into the feed system, either a leaky condenser or primed evaporator. So take alkalinity to the phenolphthalein sample. That means we have to repeat the procedure that we have first done in P alkalinity test. Then we'll add up 2 ml of sulfuric acid. So why we add 2 ml of sulfuric acid? It is just to speed up the chemical reaction which will take place next. Then we add potassium chromate, 20 drops of potassium chromate. So potassium chromate is an indicator like phenolphthalein or methyl orange. So then we will add N by 35.5 silver nitrate solution till the brown coloration result. So silver nitrate has an affinity for potassium chromate and chlorides. It principal preference, however, is for the chlorides. When it has neutralized the chloride present in the sample, it is then free to react with the potassium chromate. In doing so, it produces a reddish brown coloration. It is therefore apparent that the amount of silver nitrate solution used is the direct measurement of chloride content in the boil water sample. So this is the reaction. NaCl plus AgNO3 gives us AgCl plus NaNO3. So I hope you understood this chlorine test. So after that comes the sulphite test. So here one thing we have to remember, uh, that if we have sufficient reserve of sodium sulphite in the boiler water, there is no need to conduct the test for dissolved oxygen. So we will see the reaction. So take 100 ml of boiler water sample, add 2 ml of sulfuric acid. You will know why sulfuric acid, because sulfuric acid helps to speed up the reaction. So we will add 1 ml of starch solution, and then we will add potassium iodide solution till the sample is blue in color. So this is the word that we have to remember, potassium iodide. So I recommend that you watch this video again just a day before your oral, uh, because these things that indicator they want to listen, so you have to remember these names, potassium iodide. So if you will forget, then I think they are not going to give marks for this reaction if you will not able to tell that potassium iodide or any of the indicator name or the chemical name. Like in this we have to remember potassium chromate and silver nitrate. So it is better if you will make notes or just watch this video once again a day before your oral exams. So the boiler water is slightly acidic to speed up the chemical reaction which are to take place. Potassium iodide produces a blue coloration through reaction with the starch, but it has a preferential chemical reaction with the sulphite if it is present in the sample. Hence, when the potassium iodide solution has dealt with the sulphite present, it is then free to react with the starch present in the sample, producing a blue coloration. So it is therefore apparent that amount of potassium iodide solution used a direct measure of the sulphite content of the boiler water sample. As far as is possible, the atmosphere should be excluded in the test, otherwise an incorrect result may occur. So the reaction in this sulphite test is potassium iodide reacts with the sodium sulphite and H2SO4 gives us iodine, sodium sulphate and potassium sulphate plus water. So phosphate test. Phosphate test, normally you may have seen that on ship we have separate ampoules for the phosphate test. In that we have ampoule, we take a boiler water sample and we just break the ampoule in the boiler water sample, and the color of the ampoule change after some time. Then we match the ampoule color with the indicator that they have given, and this gives us the value of phosphate present in the boiler water. So this is another method, that take 25 ml of filtered boiler water sample and add 25 ml of the ml of vanadium molybdenate reagent. Then we have a comparator, and we will place this in the right hand compartment of the comparator. In left hand compartment we will place a blank prepared by the mixing equal volume of vanadium molybdenate reagent and demonized water, and we will let the color to develop, and after the 3 minutes we will compare it with the disc. So and we will get a reading in the ppm from the disc. So as boiler pressure or load increases with a consequent rise in the boiler tube wall temperature, sodium phosphate in the water in contact with the tube wall precipitate as crystal, causing the phosphate ion concentration in the boiler water to go down. Conversely, as the boiler load or pressure decreases, the precipitated crystal dissolve back into the sodium phosphate in the boiler water, causing the phosphate ion concentration to rise. It is in such a mechanism that the phosphate ion concentration varies from time to time. So this is called the phosphate hideout phenomenon. So I have explained this because recently they were frequently asking this about phosphate hideout phenomenon. So hideout, the phenomenon of the phosphate ion concentration in the boiler water undergoing changes due to the fluctuation in boiler load and pressure, and this is called hideout. So I hope you understood this boiler water test, and you must you like this video, and if you have liked this video, please press the like button and share it with your friend who are appearing for the orals, and do subscribe our channel Marine Expert. Thank you.